Hi there everybody, this is Ms. Cave with Comparing and Ordering Rational Numbers. In the last video lesson you saw, we looked at how we convert between fractions, decimals, and percents. And we reviewed from 5th and 6th grade skills, and we looked at some models for changing from fractions, decimals, and percents. And now we're going to look at what we do when we have numbers in different forms and we want to compare, or specifically this video, we're going to be looking at ordering rational numbers. So you should have your video notes in front of you, and we're going to go ahead and get started. All right, so you're going to see problems like this all the time. Please, when we are going through these notes, you are recording what I'm recording. So I want to see in your notes what I've written down because these are things that are going to help you. The first thing I see here is a problem you're very likely to see. We're placing the order in the boxes from least to greatest. So we're ordering from least to greatest. And while we're going through this, I also want to look at how we might say this in a different way, because sometimes you'll be asked least to greatest, and you'll also be asked things like put in ascending or descending order. So let's handle this vocabulary today as well. So when we're going from least to greatest, let's think about that. If we're going from least to greatest, we're like going in a staircase and we're going up. Okay, so we're going from least to greatest and we're going up. So when we go up, let's think about that. Would that be ascending or descending order if we're going up? If we think about something going in this up in the sky, a plane is doing this, going up in the sky. Let's think about that. Or if we're going up the stairs in our home or at the school. When we're going up, that is called ascending. So we're going to put these numbers in order. Ascending order from least to greatest. So let's take a look at what we have here. So I have numbers written in all different forms, and from the video we saw that how we can change them to the same form. Now some teachers will tell you, or maybe in the past you just put them all into decimals. That is one way you could do it, and we're going to look at a variety of ways, and we've looked at some in class already. But when they are in different form, it is important that we think about how we're going to order them, but we can also use benchmark fractions. So I'm thinking, are these more than 1/2 or less than 1/2? So that's one of the strategies. So 70/100ths is greater than 1/2, 3/4 is greater than 1/2, 60% is greater than 1/2, and so is 5 5/10 times 10 to the negative 1. So what I'm going to do for this is I'm going to go ahead and convert all of these to decimals. And we know how to do that. The first one is already a decimal, so I'm just going to rewrite it as 70/100ths. And again, converting to decimals is just one strategy. We are going to use it for this example, but we're also going to look at some other strategies. 3/4, we can do 3 divided by 4, like we saw in the other video, to convert. And I think this was an actual example we had. 3 divided by 4. If I do the long division, I'm going to get 75/100ths. Okay, so 75/100ths is going to be my decimal. And then 60% as a decimal. Remember, when I'm going from percent to decimals, I'm thinking of this as 60/100ths. So 60/100ths means I need to move my decimal point 2 places to the left because I'm dividing by 100. So this is going to be 0.60. And then our last one, we have it in scientific notation. So we need to go ahead and move our decimal point. We have a -1. So we're going to move it over 1 place to the left. So this is going to be 55/100ths. All right, and so now we're going to put them on the line over here in order from least to greatest. So I'd like you to go ahead and pause the video and give it a try. So I want you to put them in original form. So put the original forms in order from least to greatest. Okay, let's see how you did. If I look at these decimals, I'm going to compare first our place value from left to right. So they all have zeros in the ones place. So let's take a look at the tenths place. So I've got a 7, a 7, a 6, and a 5. So I'm going to see that this one is the smallest. So I'm going to write this in our box. as 5.5. I'm going to have to go to the next line here, times 10 to the negative 1. That's our smallest. All right, and now I'm going to look at the next number, which is 60%, because that's our equivalent. 60% is 0.6, so that comes next. And then now I have these two. I have two that have the same numbers in the tenths place, so I'm going to have to look at the next place value. So I'm going to look at the hundredths place. So this has a 1 and this has a 5. So 71 hundredths obviously is going to be the smaller of the two numbers. So I'm going to list three. Oops. So I'm going to list 0 and 71 hundredths here. And then our last number is 3/4. All right. Let's take a look at the next example. But pause the video if you need to make any corrections, because these go into your notebooks. All right, next example. Oops, I think I have one down here. We're going to go from least to greatest again, and we call this ascending order. So we're ordering them in ascending order. We're going from least to greatest. We're going up. To ascend into the sky would be to go up. So again, I'm going to try this one a little differently. Instead of changing to a decimal this time, I'm going to start first with the benchmark fractions, because that can save you some work. I know we all want to just get into this mindless strategy of changing everything to a decimal and comparing and ordering, but sometimes by thinking about what the numbers are what they mean, or just thinking about benchmark fractions, which is whether they're closer to 0, 1/2, or 1, we can often save ourselves some work. So what I'm thinking to myself is, which of these numbers, are there any numbers that are less than 1/2? And if there's only one, I know that will be the least number. So this one here, I know when I move my decimal point 1, that's going to be 72 hundredths, so that one's not less than 1/2. 40% is less than 1/2. 65 hundredths is not, because 5/10 is 1/2, and 4/5 is not. So what I'm going to do here is I'm just going to go ahead and put this number into the box, 40%. That's the least. I didn't have to change it to anything. I didn't have to move any decimals, but I knew it was less than 1/2, and I went ahead and now I'm done with it. Okay, so let's see what we have left. We have 7.2 times 10 to the negative first. So I'm going to go ahead and change these to decimals. I'm going to move this over to 72 hundredths. I'm moving over 1 to the left. I've already have this one as a decimal. And then for 4/5, instead of changing it to a decimal by dividing, another thing you can do is if your denominator goes into a multiple of 10, you can change it that way. It's a little easier than long division. So I know 5 goes into 10. 5 times 2 is 10. 4 times 2 is 8. So 4/5 is equal to 8/10, which is very easy to write as a decimal. 8/10. Again, I'm just using my place value. All right, and so now I can convert. Now that I've converted, I can place them in order. So we've already dealt with the 40%. We're already done with that one. And now again, I'm going to look at my place value. I'm going to look first, I've got to look at they all have a 0 in the ones place. So I'm going to look at my tenths place. And looking at my tenths place, I can see that the smallest one, this one's going to be pretty easy. I'm not going to have to look any further than my tenths place, so I know that it is 65 hundredths is my next number. And then my next one is going to be 7 2/10 times 10 to the negative 1 power. And then my last one is 4/5. That's my greatest number. So you can see we used the changing to a decimal, but we also used just some of our number sense because we knew that the 40% was less than 1/2. Okay, let's go to our next page. All right, I want you to try this yourself. So I want you to change these or use some number sense. These are going to be really close in value, so you may want to use the decimal strategy to compare them. But go ahead and pause the video try putting these in order of least to greatest. Again, this is ascending order. We're going from least to greatest. And then unpause the video and check your work with me. All right. So again, I can tell these numbers, I'm looking at them, and they are all greater than 1/2. All of them are. So I'm going to go ahead and change them to decimals. So the first one, I have a percent. So that means I have 66.1 hundredths. 66.1 hundredths. So when I'm changing that to a decimal, I'm going to move 2 places to the left. I have 66 hundredths, 66.1 hundredths, so my decimal is 0.661. This one's already a decimal. 2/3, if you do 2 divided by 3, right? You do 2 divided by 3. I'm not going to do the whole long division with you right now, but that's going to be 0.6 repeating. But I'm going to go ahead, and another way we can represent repeating values to show that they keep going is to write out 3 numbers. And that's important because if I only wrote 1 or 2 of the numbers, I would think that 66 hundredths and 2/3 were the same, but they're not. And then the next one, 6.67 times 10 to the negative 1. I'm using my scientific notation again. So this is going to be 0 and 667 thousandths. And you can see these all have the same numbers in both the tenths and the hundredths places. So when we go to compare them, they all have the same number in the ones place. So I'm going to look at the tenths. They all have a 6. All right, so I'm going to move on to my hundredths place. They all have a 6 again. So this is going to take us to our thousandths place for comparisons. This has a 6. This has nothing, which is a 0. You can use a 0 to compare. And then this one also has a 6, and this has a 7. So now let's do our comparisons that way. So the one that has the 0, let's see, we're looking at 0 thousandths, 1 thousandths, 6 thousandths, or 7 thousandths because the hundredths were the same. So I can see here that 66 hundredths is going to be my smallest number. Okay, followed by, okay, so I'm done with this one. This one has a 1, that has a 6, that has a 7, so the next number is going to be 66.1%. Followed by 2/3, you see, because of that 6, and this has a 7, so 2/3. And then my greatest number is going to be my scientific notation, 6 and 67 hundredths times 10 to the negative 1. All right. Let's move on. We're still dealing with ascending order. We're going from least to greatest. So again, this is ascending, important word. Ascending means it's going up to ascend. So let's see. I have all of these numbers and they are all less than 1/2. So I'm going to do something a little different this time. I'm going to, instead of changing them all into a decimal, I'm going to change them all to a percent. So percents are hundredths, so I'm going to change everything to a number of hundredths. And that's really not that difficult to do with numbers like this. So the first one, 2.2 times 10 to the negative 2, I am going to first have to take this, change this to 0.022, right? Because you're moving 2 places over. You moved 1, 2 places. And so what would this be as a percent? It would be 2.2 hundredths, which is 2.2%. So you can already see that this one is pretty small. And again, let's look at how I did that. I changed it into a decimal first. And then I thought, how many hundredths do I have? So how many hundredths? I'm looking at the number, how many hundredths? I have 2 in the hundredths place, so it's a 2.2 hundredths, which is then 2.2%. My next number here, I'm going to change the color so it doesn't get so confusing. I'm just going to leave it as it is, 21%. All right, the next one's a repeating decimal. So what that means is this number is 0.212121. It's going to keep repeating, okay? But for our purposes, I want to write this as a percent. So I'm going to take it to 21, right? Percents, how many hundredths? It's 21, it stops at that, but then I've got numbers after the decimal. And I'm going to go ahead and take it over 2 more spaces. 21.21%. Okay, because you move it over 2 places, but you have to put in those other numbers when you have a repeating decimal. And now let's look at the last one. When I'm converting that to a percent, 50 goes into 100. So this is an easy one. If you could just change your fraction to a fraction out of 100, it makes it really easy to convert without having to do that long division. So 50 goes into 100. 50 times 2 is 100. So I'm going to simply multiply 11 times 2. And I get 22 hundredths. So this is 22%. So now that I've converted them all into percents, I can just look at the number of percents I have and order those numbers from least to greatest. So for the first one, let's see, 2.2%, 21%, 21.21, or 22%. Okay, obviously the smaller one is going to be 2.2 times 10 to the negative second power. The second smallest, let's see, I've got 21, 21.21, and I should probably put a bar there too to show that it continues to repeat. And I have 22%. So my next one in order, after I dealt with this one, is going to be 21%. Followed by 0.21. Again, it's not the same as 21% because it keeps going. And then my largest number is going to be 11/50. Again, when you're comparing and ordering, make sure you put them in their original forms. You use your conversions so that you can compare them, but when you're looking to put them in order, you need to make sure you use the form that you started with. All right, now we're looking at number lines. Okay, so we've got matching the number with their proper placement on the number line. So you've got 4 numbers here. And I want you to put the letter on your paper where you think it goes. And you can do conversions to do that, or however you want to place them. So go ahead and pause the video, put the letters next to, so you could actually put the letter above or below each number to say where it goes on the number line. All right, hopefully you've placed your numbers and we can look at them. So for the first one, it looks like it's the smallest of these, but I can use my number line to compare. Right now I'm just looking for conversions. So if I change this one here to a decimal, it's going to be 0.4. So the correct answer for this one is going to be A, because it's 0.4 on the number line. So that's going to be my 4 times 10 to the negative 1. All right, so now 45.2%. And here's where converting and such sometimes isn't necessary for you to convert if you have a good understanding about your number line. Because if you look at the bottom of your number line, these are all numbers in hundredths. So if they're all out of 100, they're hundredths, that means they're percentages. So this one right here, 0.45, is the same thing as 45%. This is 45.2%. So that's really close. It's between 45% and this would be 46%. So I know that this must be D. Okay, and then the next one is, let's think about how many percent this is, or how many hundredths I have. I have 43 hundredths. So 43 hundredths, 435 thousandths is going to be right here in between, right? 43 hundredths and 44 hundredths. So that's where I would put 435 thousandths. Because again, how many hundredths? It has 43 hundredths, but not quite 44. In between 43 and 44 hundredths. So the correct answer for this one is going to be B. It's going to be B. And then our last one, 4/9 is going to be C. We can do that by process of elimination. But again, for something like this, for 4/9, I would do my division just to be sure. So I would take my 4, divide it by 9, place my decimal point. 9 doesn't go into 4 evenly. 9 goes into 40 4 times, because 9 times 4 is 36. Bring down my 4, and I get 40 again. 4 times 9 is 36. Bring down my 4. Bring down another 0. So you can see that this is a repeating, but it is around, if you see, it is around 0.444, and it keeps going. So I can also write this as 0.4 repeating. So let's look on our number line where that would be, somewhere after 0.44, in between 0.44 and 0.45. So this is going to be my 4/9. And my answer is C. All right. Last thing I have for you is a little check just to see how you're doing with this. I've got 2 problems for you to try on your own that you're going to bring to class tomorrow. I want you to try these. The first question is you're going to put the numbers below in ascending order. Put the original numbers in the boxes, but you're going to do some conversions to place them. And then look, this is where we have the other word. On the second one, it says descending order. So descending order means we're going down. Descending is down. So this time, don't let that trick you. You're going to go from, instead of from least to greatest, you're going to go from greatest to least, because you're going to descend. You're going to go down. All right, that's it for our video. I look forward to seeing you in class tomorrow, and we'll do some more practice with this. Have a great evening.